Okay, so our last lesson we talked about box and switch, which is just substitution, and we learned that in order to do box and switch, we had to find a variable that was alone, put a box around it, substitute it out, and then do some work with distributive property, combine like terms and other things. Today what we're going to do is actually look at how that completes all the way through for both numbers, because remember there are two variables. And so today what we're going to do is first off look and see if we can learn to identify which ones we can use this substitution or box and switch for. And then we're going to go ahead and work through a good number of problems just to make sure you've got this process down. I know that I am not there, and you've got a substitute teaching you, but if at any point you need us to stop or need him to stop the video so that you can get what you need out of it, just raise your hand, let him know, and that way you can pause it and write down whatever you need to write down for your notes. But for the most part, this is just again to show you how to do the whole process. As long as you kind of got the idea from box and switch, you should be okay. Here I cannot use box and switch because even though this x looks like it's by itself, it's actually right next to a 4y, and the equal sign is over here, so these two are not alone because they're here together. So this will not work with substitution, or box and switch is really what it is. In this problem, once you see that this x is alone, you could set up your box and switch, which means yes, we can substitute on that. If you look at the third one, none of these variables is alone. I cannot use substitution on that one, so this would not work. Again, you're going to see next week or whenever one of these things pops up that there's a second option to solve, and that's what you'll use on these here. But again, what we're learning how to do here is just kind of identify when you can use what we're talking about in these last couple days. Here, once you see that there is a y by itself and you can set up your three boxes, it means that you can use substitution. This one can be worked out the way that we learned yesterday. As weird as it looks, even this one can be worked out, because if you notice, even though y is on the wrong side, or what we would consider to be the wrong side, it is still alone, which allows us to use the box and switch. As you look at this one also, this x is also alone, which allows us to set up our three boxes and do some work from there, which again we'll see later on that that's not so bad. This one isn't initially set up, but I mean, if you're good at your numbers and you understand 2x equals 10, means you could rewrite this as x equals 5 and go from there. But again, overall, I don't think you'd see a problem like this too often, but that's for those professionals. And this is one that's really weird for people because they see two variables alone. Just pick one and set the box like this, and then once you set this up, it means that this 3x plus 1 would be going over there and working through it. So again, hopefully you remember how to do that box and switch stuff, because now we're going to look at some problems and go all the way through. Again, substitution means identify a variable as by itself, identify what that variable is equal to, and then plug it into the other one. So we write everything in front of that box, which is a 2. We trade out our x for y minus 4, and then we write everything behind the box, which is plus y equals 13. We then distribute, which makes 2y minus 8 plus y equals 13. Next thing we do, as we learned yesterday, is we combine our like terms. 3y minus 8 equals 13, and we solve using algebra by adding 8 to both sides and dividing by 3 to get y is equal to 7. Again, this is where we stopped yesterday. Today we recognize that there are two actual variables and we need both of them. So what we're going to do is we're going to take this y and we're going to plug it into one of these two equations. My advice for you is to pick the variable that has a variable by it, or pick the equation that has a variable by itself, because it's easier. So I'm going to do both of them really just to show you real fast, but I will start out with the easier one, which to me is the one that has the variable by itself. Write that equation out, x equals y minus 4, except now that we know that y is equal to 7, we can put it down as x equals 7 minus 4, which means that x is 3. That would be our stopping point, but just to show you that it doesn't matter which one you use, I'm going to rewrite the top equation also, just to prove again that it doesn't matter which one you use. And I'm going to turn this y into a 7, so we get 2x plus 7 equals 13. We subtract 7, we get 2x equals 6, and again when you divide by 3, notice you still get the answer of x equals 3. And typically they're going to want it in ordered pair form. And so once you get your x and your y, remember that x always goes first, y always goes second. Hopefully you learned this in your last class, 134A, because you were supposed to get this far. But either way, your answer comes out as 3, 7 whenever you do that. Again, x goes first, y goes second, and we have a few of these to work through, so don't feel like you should be intimidated by the fact that anything happened there. All we did was take our first answer that we learned how to do yesterday and plug it into one of the equations to find our second answer. We put our x value in the first spot and our y value in the second spot, and that was it. Let's look at another one. Here we have, again, y all by itself down here. It's equal to 2x minus 15, and we're going to put that right there. So again, we're going to write everything in front of the box, which is 2x minus 5. Open our parentheses and put 2x minus 15 inside that box, and then everything after it, which is your equals 3. We then distribute this negative 5, and you got to pay attention to the fact that this is a negative 5, which means minus 10x and plus 75 equals 3. Put your like terms together. You get negative 8x. If you need to use your calculator to do that, just type in 2 minus 10. But negative 8x plus 75 equals 3. You then do algebra by subtracting 75 from both sides, getting negative 8x equals negative 72. I don't like a negative 8, so what I usually do is switch both sides first and then divide by 8, which gives me x is equal to 9. Once again, this is where we stopped yesterday, so that part should not be so shocking to you because you kind of worked on that yesterday or before this point to try to learn that skill. Now that we have this, again, the best thing to do is to go to the equation that has a variable by itself, which in this case is y equals 2x minus 15, and simply turn our x into a 9. So y is equal to 2 times 9 minus 15, which means that y is equal to 18 minus 15, or 3. And again, once you find both answers, they typically want them in an ordered pair, x first, y second, which means that our x number is 9, 3. Today's new information is not really so out of your reach. It's not really that tough. It's just a matter of making sure you understand how to get there first. And again, if you have not at least gotten comfortable with this part, this might be a weird day for you. But if you at least kind of saw how to get here, all you're doing again is taking that number, plugging it back into one of your equations for the second number, and then putting those two values into an ordered pair. Number 3, the weird one. Pick one of the x's that's by itself, doesn't matter which one because both of these are by itself, and then put this into the other x. And so what happens is there's nothing in front of the box. I will just put 5y plus 2 and then equals 10y minus 13. Again, this is crazy because both of these x's have nothing beside them, and so what we do is we simply just plug that over on the left side of the equation, and we use our algebra experience where variables are on both sides. If you remember, whenever variables are on both sides, we move the smaller number to the bigger number, so 5 is smaller than 10, so we move it over here. That cancels out, giving 2 equals 5y minus 13, and now we're right where we're comfortable. Adding 13, we get 15 equals 5y. Dividing by 5, we find out that our answer is 3. And again, this part is what you're used to. Now what we want to do is find the second answer, and the way we do that is by picking one of these two equations. Again, the best one is the one where the variable is alone, so both of these are actually good choices, and turning our y into whatever we just found, which means that x is equal to 5 parentheses 3 plus 2, or 15 plus 2, or 17. And again, usually they want that in an ordered pair, so what we're going to do is put our x number first, our y number second, and that is usually what you're going to have to answer your problems as whenever you take a test or whenever you're doing a SAT, ACT type of assessment. Couple more here before we close out. We're just going to do 5 of them. Again, just to make sure you can see that the new process really is nothing compared to what you already know. Y is equal to x minus 6. 2x minus y is equal to 13. Here is the variable that's by itself. Here's what it's equal to. That is where my y is, which is where I'm going to put it. I write everything in front of the box, which is your 2x minus. I trade out my y for x minus 6. I write everything behind the box, which is my equals 13. The thing about a negative sign is that it pretty much just means switch everything on the inside, so you end up with negative x and plus 6, not minus 6, and that is usually where the mistake happens, is negative 6 makes a positive 6. Now you put your like terms together, 2x minus x makes x minus 6, and then to get x by itself we simply subtract 6 from both sides, getting x equals 7. Again, this part is where we went before this point, and all we're adding today is that we write one of these two equations, and again the best one to pick is the one where the variable is by itself. We'll now turn our x into a 7 minus 6, and of course we know 7 minus 6 is equal to 1, which means that our final answer, x first, y second, is 7 comma 1. Alright, one more of these before you get to work on some practice. Here we got 2x plus 3y equals 25, and we've got x equals 3y minus 1. X is by itself, 3y minus 1 is what it's equal to, and we're going to put that right here. So again, everything in front of the box is a 2. Turn our x into 3y minus 1. Behind the box is plus 3y equals 25. That is our substitution step. The distributive step, that's where you take and multiply the 2. You get 6y minus 2, and then bring down everything else, plus 3y equals 25. 6y, 3y make 9y minus 2 equals 25. Now that you're in the basic algebra mode, go ahead and solve by adding 2 to both sides, getting 9y equals 27. Dividing by 9 to get y equals 3. Again, that is a good moment. That is where we should be trying to, or where we should be able to get to as of all the work that we saw up to this point. The only thing we added today is that we go back to one of those equations that have a variable by itself, write it down, and then we take the value that we just found and we plug it in. So we did this in a rate over the last few days, or at least couple of days, to where we learned how to do the most fundamental part first. That was before this lesson, and all this lesson is telling you is to take this and plug it into this little piece here. We plugged it into this piece here, and we put it into that piece there. Those are the parts that I drew a rectangle around are the only new information that we really learned today. So what you want to do today is go ahead and take that, practice it, make sure you get used to it. You might have one more day of practicing with this stuff, and then we're going to be moving on to elimination, so make sure you make the most of it, because again, chapter 5, chapter 6 was supposed to be covered in algebra 134a, and so you won't be getting a lot of time to kind of get this down, because it's more of just kind of like a moment to try to make sure we can bring some of the stuff back into your mind that you haven't seen for the last 3 months. So again, good luck. Make sure you ask questions, make sure you work hard on this, because again, we are moving on in a couple of days.